So that was my video, right?
Oh, let's go ahead now.
Do you see it? Oh, okay, so we have the little thing, the timer. Yay, okay. Yep. All right, so today we are going to, listen up, we're going to add, we're going to do some subtraction. We will eventually multiply and divide in just a few minutes, but you do have to understand that there are many operations. These should not seem bad. The composition of functions is going to seem a little bit scary, okay? So the very first one we're going to start out with is just addition. And addition is pretty easy. All you have to do is add like terms, okay? So we're going to go ahead and write them down. 3x minus 7 plus 13 minus 2x. And all you have to do is add like terms. And put it in descending order. That is not a bad thing. So we have 3x, take away 2x, so that just gives us 1x. And then we have a negative 7 and a positive 13. So x plus 6 is our answer. And you do not have to write the 1 if you don't want to. So that's easy, okay? Now, that is our new function, okay? And this new function is called f plus g of x. All we did was add, okay? So now we're going to go through and talk about what this really looks like. It's just really a combination of them. So this is f of x plus g of x. That is just a combined version of what it would look like right there. Yes, ma'am. Malik? Okay, perfect. Thank you. Okay. All right, Malik, you're checking out. But guess what? I'm going to upload this to our new Google Classroom, so you'll be good to go. Okay? All right, ready? Here we go. So this next one, it's going to be so much better because nobody's going to interrupt me. Well, my children could, so we'll just see how that goes. Yeah.
Everybody's going to know that you called me out in Google Classroom.
That's right. Now I'm calling you out. No, you're good. All right, so again, if you see a minus sign, you're absolutely going to subtract the 2. That means that you might have to, check this out, that means you might have to distribute the minus. All right, so you might have to distribute the minus. All right, f times g obviously just means to multiply the 2. And that might mean that you have to distribute a little bit as well. And then when you are doing division, you might have to factor to reduce. Okay? So there is a possibility that you might have to factor there. So we're going to try all that and go from there. Finally, we'll see you in a few weeks. All right, so look at this one. Just looking at my problems right now, f of x, it's a trinomial. It's probably factorable. So if I end up dividing with this, I might need to factor that out. Okay? Looking at g of x, there's not even a greatest common factor there, so I'm good to go. H of x, no greatest common factor, nothing, so that one should be pretty easy. This is what I'm really going to need to reduce down potentially, okay? All right, so we're going to do a lot with these different functions. They all have a different name, and that's okay. All right, so let's start with this first one right here. It says f plus g of x. So all that is f of x plus g of x, which that's simple. We have added these before. So I'm going to rewrite this. And then I'm going to write this one, put an addition sign. Now, there's no reason for parentheses here, so I just got rid, if there were parentheses, I'd get rid of them. I might have to add parentheses for when I'm doing like a subtraction problem, and I know I have to distribute that minus. I might need to put some parentheses around some stuff. But right now, adding easy peasy. All right, let's do it in descending order, STD form. So what comes first? Perfect. Minus 4x plus 1. Boom, shakalaka. That's it. Okay? Now, it says identify any restrictions in my domain. Now, think about what an x squared function looks like. It's like this, right? It's a parabola. So my domain for a parabola, there's no cutoff, there's nothing. Domain is all your x values, right? Now range, if I went, there would be an issue with my range because There's nothing at the bottom until I get to that point. Domain is all reals for this one. There are no restrictions, okay? You can have restrictions. See where it says restrictions right there? You can have restrictions if you have a denominator. I just spelled that wrong. Demon.
So did I.
Let's try that wrong. Denominator. All right, what is the one thing you can't have in a denominator? You can't divide by what? You can, yeah, okay, you can't have an I. I like that. We're not going to do I's today, though. What else can you not have in the denominator?
No. Oh, 0.
Well, I can't divide by 0. Okay. So you cannot have a 0 in the denominator. So right here, you can have restrictions in the denominator. You can't have 0 in denominator. So you can't have 0 in denominator. Okay? So we'll get to that. That's really when we have restrictions in the domain. All right, so here we go. On number 2, this is the same thing as saying f of x minus h of x. Now the x just means that I have x's as my variable of input, right? And that is my function f and my function h. All right, so when I do this, because I have the minus, I'm going to have to distribute my minus. So that means I'm probably going to need to use some parentheses. So I can go ahead and write the first function f minus, and I'm going to use parentheses around h because I know that I have to give that minus to all of h. Alright, so this is easy. This should not be too bad. So we have a minus x and a minus 2. Carry everything else down. Descending order. And there you go. And we have another parabola. It's another quadratic right there. It's positive. It's opening up. So my domain, again, is all real numbers. Is that easy enough so far? Okay, let's do a few more. So now I have h times g of x. So I'm just going to do h of x times g of x. And since I'm multiplying, I am going to use parentheses here because it'll show me how to multiply them out, okay? So my h of x, x plus 2, and g of x, 4x minus 3. Well, we know how to do that, right? We know how to do that. So that's my h. That's my g. And now all we have to do is multiply. So do your first set. Then do your second set. And then go ahead and combine like terms. So I have 4x squared plus 5x minus 6. Dun, 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 dun. What is the shape of that function? Quadratic. It's another parabola, right? It's an x squared. So what is my domain for this one? Oops, domain. All reals. Domain. All reals. Perfect. Okay, now, division. This is where it gets a little crazy. Remember, you might have to factor to be able to reduce as much as possible. Okay, so let's go ahead and look at a couple of these, and then we'll get to the crazy stuff on the back. All right, so right here, f of x divided by g of x. All right, so let's go ahead and stack that f of x. What is it? Oh, it's h. Thank you. F and h, and then all over x plus 2. Now, before I get super excited and try to factor this, let's go ahead and talk about the domain, okay? You cannot have a 0 in the denominator. You can't have 0 in denominator. What is the 1x value that I cannot plug in here? A -2, right? Perfect. So if I put a -2 in here, and that's a +2, then I get a 0 in the bottom, and that's bad, right? So if I can use any other number in the whole wide world besides a -2, okay? So on my domain, I'm going to write domain, and I'm just going to write x can't equal -2. Because if you were to plug in a -2, it would be some bad news. All right, are we good so far? Okay, now we can try to factor this and see if it works. If it's not factorable, then we just have to leave it. So we're going to come over here and attempt, because it's a trinomial, I'm going to attempt to factor. So I'm going to come over here. I could use synthetic. I could set up a -2 and try to factor it out and see if I get a remainder of 0. And if I get a remainder of 0, when I factor it out, then I know that they divide out. Or I could use my graphing calculator, or I could try to factor this way. So I'm going to do it 2 different ways here, okay? First, I'm going to ask myself what multiplies to give me 4 and adds to give me -8. So are there any 2 numbers that multiply to give me +4 and add to give me -8? I can't think of them, okay? Now, wouldn't this have to be a factor of it so that they would cancel out if that were factorable? Okay, do you see what I mean, Joby? Like, if this were to be able to factor into 2 binomials, and I could cancel that out, wouldn't -2 have to be a root of it? Do y'all see that? -2 would have to be a root. X plus 2 equals 0. So if I were to graph this, x squared minus 8x plus 4. Oh my gosh, they have suspended rec. All rec's been suspended too. Ah, okay, I'm going to have a lot of free time. All right, so check this out. Okay, so if I graph this right here, does it appear that it passes through x equals -2? Do you see this x plus 2? Wouldn't the root of that factor be -2? And does it pass through x equals -2 here? No, it does not. So that means, and these aren't even whole numbers. These aren't even whole numbers there. So if you can tell on there that, that there's no way that this is factorable into whole numbers, okay? So what I'm going to do is, we tried to factor, but we can't factor, so we're done. This is my final solution right here. So we attempted to factor. Another way that Allison just said, she was like, well, can I see it? Can I do synthetic division to see if it would factor? And I could try 1, -8, and 4. Notice I used a -2 right there. And I could do this. And I get 24. That means that x equals -2 does not go into it because I didn't get a 0 remainder. Okay? So there are a few different ways to look at that. Okay? All right. So you couldn't reduce that one at all, and x can't equal -2. Easy, easy, easy. All right. Very last one. This one should not be that difficult. We know that we have things that don't factor. So h of x, x plus 2. G of x is 4x minus 3. Those do not reduce each other, okay? This binomial and this binomial, you can't just reduce an x You can't just reduce a 2 and a 4 and be all willy-nilly. Those do not reduce. That entire binomial would have to reduce with that entire binomial. So you can't reduce this one at all, and you are done, except you have to do the domain. And we're going to be doing domains on these for a while, so just make sure you get used to it, okay? All right, now, this is really weird. What number would I have to plug in for x for it to make the denominator 0? There's one number that x cannot be. Oh, man. Set this equal to 0, and it'll give you the one number that x cannot be. So, and I'll show you how it works. So we're going to solve this for x. So add 3, and then do what? Divide by 4. And you get 3/4. X cannot be 3/4. And if I were to plug 3/4 back in there, wouldn't it make my denominator 0? Yeah, you can check it out and see. Let's see. 4 times 3/4. What is it? Minus 3. And I get 0 back. Okay? So if sometimes you can just look at it and know what x can't be, like x couldn't equal -2 here, that was easy. But if you can't figure out what it is, set it equal to 0, solve for x, and that is the one x value it can't be, because if you were to plug it in, you get a 0 in the denominator, and that's illegal. All right, good. Flip it to the back. Let's go. All right, now this is the new stuff. We're going to do exactly one of the ones at the tippy top, and then I'm leaving you to do the rest, okay? All right, so here we go. On number 7, it says find each function value. So they want you to do f plus g evaluated at -2. Okay, there are 2 different ways you can do this. You can plug in -2 into f, and then plug -2 into g, get your answers, and then do what this operation says. Add them up. Or you could go ahead and add the 2 functions and then plug -2 in at the end. You can plug -2 in at the beginning when they're separate functions, or you can plug it in at the end. It doesn't matter. Okay? So, do y'all want to plug it in first?
Wait, so are you talking about, like, do f of x with -2?
G of x with
Why
-2?
can't you just write them all out with blankety blank x is fine?
You could add them up and then do that. Yep, either way, it works either way. So you can either plug them in separately, or you can add the functions, and then wherever the x's are left, once you add the functions, you can put -2 in. Okay? So we're going to do, they're both having to be added together, so we're going to do f evaluated at -2 plus g evaluated at -2. And then we will add all of our answers at the end. Okay? All right, so f evaluated at -2. Draw your blankety blanks like you said. Here's f. So we have 2 blankety blank squared minus blankety blank minus 12. And then we have our g function plus blankety blank plus 7. And of course I'm going to put -2 in every single one of them. And then at that point, what am I putting in -2? And then at that point, you can put it all in your calculator, and it should not be a problem at that point. Okay? You can either evaluate it by hand or put it all in the calculator. Literally, just put it all in, and you get an answer. Easy enough? All right, this one right there, the same thing. You want to plug a -1 in right there. So this just means do f evaluated at -1 times g evaluated at -1. And your final answers, you will multiply. Is that okay?
So when you do this one, do them separate and then multiply.
Yeah, just like we really did there, but with addition, I could just carry it all the way down. So if I do f evaluated at -1, You're going to get an answer from that, and then you will multiply it with the next one. You can multiply all with an x in the equations. Leave the x in the equations, multiply them, and then whatever your final answer is, you can plug -1 in at that time. Yes, ma'am. All right, and now g evaluated at -1 is -1 plus 7. All right, so now we can do this, and you can find your answer here, find your answer here, and then we'll add them up. So we get a 6 here, multiply, and then figure out what your answer is here. -1 squared is 1, 1 times 2 is 2, plus 1 is 3, minus 12, -9. So negative what? 54? All right, easy enough. All right, so here comes the very, very last thing right here. This is called the composition of functions, and this is kind of odd. So this is when you, instead of inserting a number into a function or leaving, or adding functions or subtracting, we are going to insert another function into a function. That's crazy, right? So we have seen a function machine before, and y'all have seen it where it looked like this. I'm going to draw my function machine here. So if I have a function f of x equals x minus 2, and I wanted you to do a function evaluated at 5, then you guys have seen this before, your little function machine. What am I going to plug in for x there? 5. 5 minus 2, and spits out 3, and we're done. That's the function machine, okay? Now, instead of a number being put in place of x, I'm going to put a function in place of x. That's crazy. It's kind of fun, though, okay? It's not hard. It's different, but it's kind of fun, okay? So now what I can do is, if I have a function machine, and I have my little f of x right here, and let's just say that I have this g of x, which equals x plus 5, then I can take my little g of x function, and if I wanted to put my g function in my f function, then wherever I see an x in the f function, I'm going to put that whole thing in its place. So I always plug something in place of x, right? So instead of just plugging in a 5, I'm going to plug in x plus 5, and then I still have that minus 2 hanging off the end, right? Now, simplify that, and that's your answer, which is what? X plus 3. And that's called the composition of functions. It's like when you insert one function into another function. And they make function babies. There you go. All right, so here we go. All right, so let's look at this first one. It's really not that bad. This is how we write it. So if you have something that looks like this, f circle g of x, so that O just means f of g of x, okay? That is the same thing as doing this. It's really weird, f of g of x. And we read it from the inside out. So this right here on the inside is called my input. So this is my input, and it's on the inside. So I'm going to input the g function wherever I see an x in the f function. We can do this. All right, so it's kind of fun. Like I said, it's not hard. It's just weird. All right, so here we go. We're going to rewrite this one. We have 3 different functions right here. F circle g of x just means f of g. It just goes straight in the order that it is. Whatever variable you see first, that is the variable that you're going to write first. All right, so this is my input. Okay? So I'm going to use the f function, and since I see this first, you're going to, since you see it first, you're going to write that function with blankety blanks. So here's my f function, Racha. Alright, the only place in the f function that I see a blankety blank would be right there at x cubed plus 8, right? So I'm going to write blankety blank cubed plus 8. And since this on the inside is my input, that's what I'm going to put, Racha. So what is my g function? X minus 1. Are you good? All right, now technically we need to go ahead and try to combine like terms here, which would mean x, oops, that's a minus, x minus 1 times x minus 1 times x minus 1 plus 8. I'm going to go ahead and do this one, but I'm not going to do 13. So if you want to go ahead and mark out 13 so you can keep going in this box, you can. All right, now we're back just to simple algebra. All you had to do is plug one function in another, and now what I need to do is multiply all this out, and then I'll be done with it. Many of you messed up how to multiply this out on your last test, so I'd be paying attention to it. Okay? Y'all just thought it was x cubed minus 1. And it's not. That's right. It's not. All right, so this right here, I'm going to go ahead and multiply this out. So x squared minus 1x minus 1x plus 1. And I still have the x minus 1 on the outside, and I still have the plus 8 on the end. I'm going to do the operation in parentheses first. I can combine this together. Some of y'all can see how this is relating to the difference of cubes. A squared, b squared. All right, and pull this all the way down. And now, how do I solve this out? Yep, distribute again. So we have x cubed minus 2x squared plus x, and then do the minus 1. Minus 1x squared plus 2x minus 1. And then, of course, I still have that plus 8 on the end. All right, we are almost done. That one was tough because I had a cube in it. Now, descending order STD form. Let's go. Walk it. X cubed minus 2 minus 1. So what do we have? Did I do that right?
You have the x squared instead of
Where?
x cubed, the very first one.
Cubed?
Yes.
Sorry about that.
And then 3x squared.
Minus 3x squared?
Yes.
And then
Plus 3x.
plus 3x
And then plus 7.
plus 7. There we go. Okay, now let's do one more. We're going to do one that, we're going to do the h of g of x, and then we are going to be done for. No, it does not say domain, so we're good. And that one would be a cubic function. It'd be all reals as well, just there is no break. Yes.
On number 15 to 16, whenever it says that it's the 2 and the negative 6, is that kind of like what we did up there at the very top?
Yes, first you need to do the composition of functions,
Okay.
and then you'll plug negative 6 into it. Yep. All right, ready? Number 12, number 12. We're almost done, almost done. I'll probably do one of those in just a second. H of g of x. Here we go. So that is rewritten as h of g of x. Now, whatever the first function is, that's the function you're using. Whatever's on the inside is your input. So I'm using the h function, which is 5 blankety blank minus 3.
Are we doing 14?
You're not going to need, or you're not, we're almost done with 12. We're not doing 14. But 12 is not going to take a lot of space. So you're good. All right, so the h function is the one that we're going to use because we see the h function first. So this is the function you use. This is the one that you input. What is my g function? X minus 1. Now this one's a whole lot easier to solve out. So I'll get 5x minus 5 minus 3. And so my final answer is 5x minus 8. And you're done. So depending on the complexity of the function, it can make it a little bit scarier. Okay? That's easy, right? That's not bad. Just remember, the first one is the function you're using. The inside is the input. All right, let's do 16 really, well, let's do 15. Let's do 15 real quick. All right, so this is what we are doing on this one. This is g of h of 2. All right, so the easiest way that I can do this is work from the inside out. I would go ahead and find h of 2. This is the way I've always done it. Go ahead and find h of 2. So evaluate h at 2. So how would I do that? What would that be? 5 times 2 minus 3. And so you get 10 minus 3 is 7. Are y'all good? So now what I'm really doing is g of what? 7. And so my g function is x minus 1. So we're going to plug in a 7 there. And so the final answer is 6. Easy enough.
When we first started to do that, I was kind of confused.
Is it better now?
Like, I understand like what we do.
Yeah, so you're sort of putting a function inside of another function. So for those people that really love algebra, they're like, what else can we do with functions? Okay. All right, we're totally done right now. You do have some extra work that you can do on that starting Monday. I'm going to go ahead and stop the video. 32-minute lesson. Woo!